Great, so welcome to Mutating Meetup with GraphQL. Let's get started. So first, what is Meetup? Meetup is a community platform, and we bring together people from various backgrounds with common interests and allow them to do things together. In fact, we've been doing this for a while. So what would you say? How old do you think Meetup is? A, 21, B, 12, C, 17. Just kind of yell it out. C, okay. So there's like a mix of A and C here. So if you guessed A, you'd actually be right. So although we've been around the block and we've seen some things, we're still here and we're still doing what we do best, and that's using technology to get people off of technology. And so enters GraphQL. Over the past 3 years, we've steadily adopted GraphQL as a primary means of accessing and exposing data, but this hasn't been without its challenges. And so my goal today is to share with you 3 key challenges that we faced and how we're overcoming them, and hopefully this can prevent you from gaining any unnecessary battle scars in your GraphQL journey. So the first one is related to a poor architecture setup. The second, insufficient to no caching. And then the third is a steep learning curve. We'll start with how our platform is architected and then what challenges this presented during our adoption of GraphQL. So here's a high-level architecture diagram. And at first glance, this likely seems okay. But I want you to take just a few seconds looking closer. Can you spot the problem? Okay, let me give you a few hints. Is it 1, we have a lot of users who send unique GraphQL requests? Maybe 2, we have multiple client systems, each with their own in-memory caches. Or 3, a primary GraphQL API that handles most of the traffic. 4, a secondary API that listens to the first API. Or 5, the secondary API talking directly to the database. Now, I know when I said this, you were kind of like shaking your heads, and pretty much all of the above could really be problematic in your system. And yeah, you're right. But it actually took us a while to get to this point where we recognized how many things we were doing wrong in our architecture. And this happened because no one person had a full understanding of the entire system and the downstream impacts of any changes that we were introducing. And so I'm going to talk more about this later when I get to the portion of how it was like a steep learning curve for us. Now, for this portion of the talk, I'm going to focus on this back end, 3 through 5, and what we're doing to fix this situation. But first, it starts with a really sad story. We had a dream of launching a new events product at Meetup. And if you have a new product, then you're going to need new things. You're going to need your own web application. Of course, your own GraphQL API. And if you're going to do that, you might as well have a separate database. And so, yeah, it sounds a little sarcastic, but honestly, that was the best decision at the time. But like many dreams, this didn't come true. We scrapped that project, we decommissioned the database, but then we decided, hey, let's leave everything else. And then more and more engineers started to build on the new thing. And as we built more, that's when we noticed some issues. So like what? Here's an example. We get this request for a member's profile. It goes through our CDN, then through our API gateway, and on to the primary API. So far, this probably seems legit. But then the primary API takes that one request and fires off multiple requests to the secondary GraphQL API. And in most cases, it's going to 5x the one request that it just received. But it actually gets much worse than this. Did you notice that the primary API is on Lambda? This would often lead to site-wide instability. How? Anytime there was a traffic spike that happened to correspond with the launch of the secondary API, a ton of Lambda instances would all get created attempting to get through at the same time. So we were basically DDoSing ourselves. Like at this point, I kind of want to hide behind the podium in embarrassment, right? But with all that being said, the elephant in the room was, well, what should we do? Majority of the clients were using the primary API. The majority of the web and full stack engineers felt comfortable contributing to the primary API. And we also had dozens of queries and mutations all running on the primary API. So what would you do? You could just yell it out. I like audience participation. What would you do? Anybody? You would remain baffled. Okay, great. It's fair. It's fair, right? So we decided, hey, look, let's get rid of the middleman. And it's taking us some time to actually do this, but we're starting to see light at the end of the tunnel. I estimate that we've moved at least 25% of our primary API traffic to point directly to the secondary API at this point. And the end result is increased performance and lower cost. In fact, we're targeting about a $29K reduction in our monthly bill by making just this change alone, which means there's a Domino's pizza party in our future. Okay, but during this process, it really opened my eyes to how much there is to know about any given technology. Likely when you were first introduced to GraphQL, it took you a minute, but then you got it. You were like, there's one endpoint, queries, mutations, subscriptions. I know GraphQL, right? You ask for some data, and that's the data that you get. But it's much more nuanced than that, especially when it comes to a larger system that's being developed by multiple teams. You need at least one person who constantly has eyes on the performance and cost implications of each architectural change. So now for a bit of trivia. Fill in the blanks. There are only two hard things in computer science: blank blank and naming things. Yes, very good, right here in the blue shirt. If you guess cache and validation or anything with the word cache in it, you are right, because caching is so complex. If you've ever had to add caching to something, I feel your pain and I'm with you in this moment. So that brings me to the second key challenge that we faced, which was insufficient to no caching. Now, caching is critical, not only because it reduces the latency of your system, the DB IO costs can really add up. This is a screenshot of the Cost Explorer in AWS, so we're AWS shop, and it allows you to see where all your millions are going. And for us, it was mostly to the DB IO. That was the #1 front runner month after month after month. And I remember, I said Meetup has been doing this for 21 years. That's a lot of data and a lot of legacy systems that we have to deal with on a daily basis. But how do you attack a problem like this? We started directly with the secondary GraphQL API. This API is using the GraphQL Java library, and that library offers data loaders. But not just your regular old data loaders that have special caches that can read from any external system, something like Redis. Okay, so here's how we do it. We have a Java file where we can register our loaders. In this example, it's for one resolver that returns whether an event is featured or not. And then we define the value cache, which consists of a key to be used in Redis, the desired duration of the cache, and then the type of class to be serialized. So just in case you thought you were going to get through this entire talk without seeing code, you just saw 9 lines of code, you're welcome. And now, let's see how this thing works. So you get a request, and on the back end, we have our database, the Redis instance, and some data loaders. When you're using data loaders, various promises are created for the pieces of information that you're requested. This is an asynchronous process. Each function associated with a promise will see if it has that data available. If not, it'll grab it from the database and store it in Redis for quick access later. And finally, once all of your data has been gathered, it could come from a combination of data that the loaders had cached or from the database. The key thing here is that with the GraphQL Java data loaders, every piece of data that you've requested in your query won't necessarily hit the database in order to get it. Now, here's the end result. We've seen a steady decrease in our read operations since we've begun adding more data loaders that have value caches. And now you can see we're no longer living our lives as if money grows on trees. Instead, as an organization, we're constantly looking for ways to further optimize our hosting costs. And that brings me to even more caching. As I mentioned earlier, caching is super important, but you need to do it at the appropriate layer. And we've only considered one portion. And that's when a request has already made it all the way to your GraphQL API. It's much faster and cheaper to stop it before it even gets there. And that's where client caching, cache control headers, and your CDN are your friends. Well, they could be your friends. But first, you really need to understand how each tool and library works. What's worse than no caching is when you think you're caching, but you're not actually caching. And let's look at a few examples. So since I love to have fun, I will welcome you to today's episode of Is It Cached? And I'll be your host. Okay, so let's start with the easy one to kind of like warm you up here. We're gonna make 2 requests. Let's assume you have your normalized cache up and running. And here's the first request. We wanna get access to a member's ID, name, and email. Now the second request comes in. This time, we only want the ID and name of that same member. What do you think? Is this data gonna be in the cache? Yeah, good. Okay, someone in the back gave me a thumbs up. Yeah, it will, right? Because your cache key is often the ID and the type name, both pieces of information that you're trying to get in your second request. The first call will store that data in the cache, and then the second call will read from the cache. Great, now let's try another one. For our third request, we've just added one more field, the member city. What do you think will happen this time? Is this gonna come back from the cache? No, right? Somebody was saying yes, I won't point you out. But why? Because all of the requested data has to be in the cache for the data to be used. That means even though that set of data is already in the cache, Apollo will just request all of it again. And honestly, we could probably play this game for the rest of the day. I've just been baffled by all the things I've learned around caching. So, what do I want to share exactly like what we learned during this process. We know nothing. Or better said, don't assume anything. As we began to implement these various caching strategies, we realized that we honestly need to learn more about how things work. We had to increase our observability and monitor our daily costs more closely. This ultimately led to us finding a gap in our understanding, and once it was addressed, we began to save hundreds of dollars per day. So tell your boss it was worth sending you to this conference. Okay, so continuing with this train of thought, the final challenge that we faced during our journey is the steep learning curve. Or more specifically, it was almost as if 1 or 2 people knew how things would work, and then others were just left trying to figure it out all on their own. And that's definitely not what you want. What made the situation more difficult for us is that we have a variety of platforms and languages that we're actively using at Meetup. So we have Kotlin and Swift in our native app monorepo, which is running Kotlin multi-platform. Then we have the first API, which is written in TypeScript, and a separate monorepo, which is used by a React application on Next.js. And then finally, I already told you about the secondary GraphQL API, which was written in Java. So just imagine all of this happening at the same time. For example, let's say you want to reduce duplicate data in your normalized cache. With Apollo Kotlin, you could define a field policy declaratively, just like what you see here. And then maybe in React Apollo, you could define a read function for the group field. They essentially do the same thing. But this difference in syntax and terminology often leads to knowledge silos. I remember just personally looking through how the Apollo client was configured for a web application, and then I compared that to what we were doing on Android, and everything was just completely different. They had type policies, possible types, merge functions. I didn't see any of that on Android. Were we potentially missing out on some performance benefits? What did the web engineers know that we didn't know, right? This is what happens. So put yourself in our shoes. What would you personally do to ensure that GraphQL knowledge is spread more or less equally among engineers in your company? This is a question to the audience. Okay, that's great. That's a great idea. So one suggestion was to share the metadata among all the teams. So there's just one artifact that everyone is using. Anyone else this side of the room? You've been quiet. Any ideas? How could you spread this GraphQL knowledge among your team or your company? Yes. Okay, you get a sticker later. All right, behind you. Yep, that's great. So he mentioned having a technical talk and also having a singular GraphQL resource that everyone can consume. I'll just hear from like one more person. What else could you potentially do? Reduce your tech stack. Yeah, it makes it a lot simpler. And so, yeah, thank you for those solid ideas, because to be honest, it's still something we're really trying to figure out. But let me just share what we're doing for now. So our primary goal is to help all engineers be self-sufficient. We keep our GraphQL API schema on GraphQL Hive. This provides the ability to explore the various fields in the schema. A common question that I see all the time on Slack is, how do I query for X, Y, or Z? And instead of simply providing the answer, I encourage everyone to check out GraphQL Hive. I will even create short videos in Slack to show them how they can check it for themselves rather than telling them directly, because my goal is to avoid being a knowledge hoarder. Instead, I want everyone to feel comfortable working with GraphQL in our organization. Perhaps you've heard this phrase, each one, teach one. The idea is to spread knowledge for the betterment of your community. And this is why we actively encourage pair and mob programming. When you work with someone in this way, it helps them to make the knowledge their own. And finally, we use automation as much as we can. Like, we're a GitHub shop, we take advantage of various GitHub actions. This is just a snippet of a job we run when someone opens up a PR. We detect that they've changed a GraphQL file, then we label this PR as having GraphQL changes. That way, any reviewers can be on the lookout. This way, we really can ensure GraphQL best practices, and we have many such things like this so that everyone is kind of getting familiar about GraphQL and the potential to impact the clients, etc. Like many things in life, I view Meetup's adoption of GraphQL as a journey. There were some bumps along the way and even a few major potholes. Yet we're much farther along now than when we started, and I'm confident that there will be more fun and challenges to explore ahead. So thank you very much. That is my talk. I will be sharing these slides on Twitter, along with some extra resources that I didn't get a chance to cover, and I'm very, very happy to take questions now.
There's a microphone if people want to ask questions.
Any questions? Okay, we have a lot of time, so you can also just come up and take selfies with me at the end. So still fine. You thought I was joking. Okay, all right, right here. Yeah. So what happened was we started a new product. It was going to be like a sort of a competitor to our existing events platform. And we ended up creating like a new web app, a database, and a GraphQL API for it. And that was, of course, running on Lambda because you build all new things on Lambda. And then we scrapped that project, but we only deleted the database. So then everyone started hopping on the new thing because it was cool, but didn't realize that it was costing the company likely millions. And only now are we at the point where we finally realize, wow, that was really expensive. So we are getting rid of that first API that's running on Lambda, that's written in TypeScript, et cetera. But that's a great question. Anyone else? Don't be shy. Any questions? Yes.
What kind of database do you have? Do you have a lot of different data servers, or is a single database on which you're trying to build this application?
So we're running on AWS Aurora. We have one write instance, 6 read instances. The people who were at the unconference with me yesterday, there was a small table of them heckling me because we don't properly have indices and foreign keys on our database. So that's also contributing likely to the fact that we have to have 6 read instances. But we're gonna get there. I did message my whole team on Slack and was like, what are you all doing? I love you, but what are you doing? So yeah, there's a lot of conversation going on how we can improve that as well. But that's a great question. Anyone else? All right, well, enjoy the rest of your conference.